In this tutorial, we'll learn about Pandas data frames, how to create them, manipulate data, and perform basic data analysis using Python. To start, we first import the Pandas library by writing import pandas as pd. The word pd is simply a short alias for pandas, making our code shorter and easier to read. After importing the library, we create our dataset. Our dataset contains information about 4 students, Josh, John, Sarah, and Emily. We also include their ages, which are 20, 25, 30, and 35, along with their grades, which are 100, 98, 100, and 95. Next, we store this information inside a variable called data. The data is organized into categories such as name, age, and grade. Each category becomes a column in our data frame. Once the data is prepared, we create the data frame by writing df equals pd data from data. This command converts our raw data into a table format with rows and columns. A data frame looks similar to an Excel spreadsheet because it organizes information neatly and makes it easier to understand. Finally, we display the data frame by writing printf. When the program runs, Python prints a table showing all the student information in a clean and organized structure. Each row represents a student, while each column represents a specific type of information, such as name, age, or grade. Learning how to create a data frame is an important first step in working with data, because most real-world datasets are stored in tabular form. Once your data is inside a data frame, you can filter it, sort it, analyze it, and perform calculations with just a few lines of code. This makes Pandas one of the most useful tools for anyone interested in programming, data analysis, or artificial intelligence. In Pandas, dfhead is used to display the first few rows of a data frame. By default, it shows the first 5 rows, which helps us quickly preview the beginning of the dataset. On the other hand, dftail displays the last few rows of the data frame, also showing 5 rows by default. These functions are very useful for checking and understanding your data without printing the entire dataset. In Pandas, df.info is used to display important information about a data frame. It shows the number of rows and columns, column names, data types, and the number of non-null values in each column. It also provides memory usage information. This function is very useful for understanding the structure of your dataset and checking for missing values. To select a single column in Pandas, we use the column name inside square brackets. For example, dfName selects the name column from the data frame. This returns all the values in that column and is useful when working with specific data. To select multiple columns in Pandas, we use double square brackets with the column names inside a list. For example, dfName, age, selects both the name and age columns from the data frame. This is useful when you want to work with only specific columns from your dataset. We use df_iloc to select rows based on their position. The iloc function stands for integer location. For example, df_iloc0 selects the first row of the data frame, while df_iloc1 selects the second row. We use dfloc to select data by labels instead of position. For example, dfloc0 name selects the value in the name column from the row with index label 0. This is very useful when you want to access specific data using row labels and column names, rather than numerical positions. Unlike iloc, which uses index numbers, loc works with actual labels in your data frame. In Pandas, we can filter data using conditions. For example, if we want to select only the rows where the age is greater than 25, we write df_age 25. This expression checks each value in the age column and returns only the rows that satisfy the condition. Filtering is very useful when you want to focus on specific parts of your dataset and remove unnecessary information. In Pandas, we can filter data using multiple conditions. For example, if we want to select rows where the age is greater than 24 and the grade is equal to 100, we write df_age 24 and df_grade equals 100. Here, each condition is placed inside parentheses, and we use the and symbol to combine them, which means both conditions must be true at the same time. This helps us narrow down our dataset and focus only on the specific rows that meet all the required criteria. In Pandas, we can easily add a new column to a data frame by assigning values to a new column name. For example, if we want to add a column called salary, we write df salary equals 5,000, 6,000, 8,000, 9,000. This creates a new column in the data frame and fills it with the given values for each row. It is important that the number of values matches the number of rows in the data frame. Adding columns like this helps us expand our data set with new information quickly and efficiently. We can create a calculated column by performing operations on existing columns. For example, if we want to calculate a bonus that is 10% of the salary, we write df bonus equals df salary 0.10. This creates a new column called bonus, where each value is calculated based on the corresponding salary value. This is very useful in data analysis because it allows us to derive new insights and features directly from existing data. We can update values in a data frame using dfloc. For example, if we want to change the age value in the row with index 0 to 40, we write dfloc 0 age equals 40. This command selects the specific row and column using labels, then replaces the old value with the new one. It is a simple and effective way to modify existing data in a data frame when updates are needed. We can delete a column using the drop function. For example, if we want to remove a column named bonus, we write df drop bonus access equals 1. Here, access equals 1 tells Pandas that we are working with a column, not a row. If we wanted to delete a row instead, we would use access equals 0. This is very useful when cleaning data and removing unnecessary or unwanted columns from a data frame. We can sort data in a data frame using the sort values function. For example, if we want to sort the data by the age column, we write df sort values age. This arranges the rows in ascending order based on age by default, from smallest to largest. If we want to sort in descending order, we can use df sort values age, ascending equals false. Sorting is useful when we want to organize our data in a meaningful order for better analysis and understanding. We can create missing data using none or numpy-non. First, we import pandas and numpy. Then we create a data set where the name column contains values like John, Josh, and none, and the age column contains values like 25, np-non, and 30. After that, we convert the data into a data frame using PD data for metadata, and display it using print. When we run the code, the missing values appear as nan, which shows that the data is incomplete and may need to be handled before analysis. We use df-isnl to detect missing values in a data frame. This function checks each cell and returns true if the value is missing, nan or none, and false if it contains valid data. It helps us quickly identify where data is incomplete. For example, when you run df-isl, you get a table showing which values are missing in each column. This is very useful in data cleaning because it allows us to locate and handle missing data before performing analysis. We can count missing values using df-isl sum. First, df-isl checks each value in the data frame and marks missing values as true. Then, sum adds up all the true values in each column, giving us the total number of missing values per column. This is very useful in data analysis because it quickly shows how much data is missing in each feature, helping us decide how to clean or handle the dataset before further processing. We use df-fillna to replace missing values in a data frame. If we want to fill all missing values with 0, we write df-fillna 0. This replaces every nan or missing value with 0, making the dataset complete and easier to work with. This method is very useful in data cleaning when we want to handle missing data quickly before performing analysis or calculations. We use df-dropna to remove missing values from a data frame. This function deletes any row or column, depending on the settings, that contains nan or missing data. For example, when you run df-dropna, it removes all rows where at least one value is missing, giving you a clean data set with only complete data. This is very useful in data cleaning when you want to work only with fully valid records before analysis. We use CSV files to store and read tabular data. To read a CSV file, we use PD read CSV student CSV, which loads the file into a data frame so we can work with the data in Python. After reading and processing the data, we can also save it back to a CSV file using df2 CSV output CSV, index equals false. The index equals false part ensures that the row index is not saved as an extra column in the file. This workflow is very important because it allows us to easily import real-world datasets, analyze them, and export the results for later use. We use the grub function to group data based on a specific column and perform calculations on each group. First, we create a dataset that contains two columns, department and salary. The department column includes values like IT, HR, and HR, while the salary column includes values like 5,000, 6,000, 4,000, and 3,000. Next, we convert this data into a data frame using PD data from metadata. After that, we use the grub function to group the data by the department column. Once the data is grouped, we can apply aggregation functions such as sum to calculate total salaries for each department. For example, df grub department salary sum adds up all salaries within each department. This means the IT department's salaries are combined together, and the HR department's salaries are also combined separately. The grub function is very powerful because it helps us summarize and analyze data based on categories, making it easier to understand patterns and compare different groups in a data set. We can calculate the average salary for each department using the grub function along with mean. First, we group the data by the department column, and then we apply the mean function to the salary column. For example, we write df grub department, salary, mean. This groups all employees by their department and then calculates the average salary for each group. So, the IT department will show the average of its salaries, and the HR department will show its own average. This is very useful in data analysis because it helps us understand the typical value of a group and compare different categories easily. In Pandas, there are several very useful beginner functions that help you explore and understand a data frame. First, dfhead is used to display the first 5 rows of the data set, which helps you quickly preview your data. Similarly, dftail shows the last 5 rows, which is useful for checking the end of your dataset. Next, df.info provides a summary of the data frame, including column names, data types, and the number of non-null values. This is very helpful for understanding the structure of your data. df.describe gives statistical details like mean, minimum, maximum, and standard deviation for numerical columns. We also use dfshape to find out the number of rows and columns in the data frame. df columns shows all the column names in your data set. Finally, df types displays the data type of each column, such as integer, float, or object. These functions are essential for beginners because they help you quickly explore, understand, and analyze any dataset before doing deeper data analysis. You have successfully completed the Pandas data frame tutorial. In this tutorial, you learned the fundamentals of working with data frames, including creating, reading, updating, and analyzing data using Python. You also explored important operations such as selecting rows and columns, filtering data, handling missing values, and performing basic data manipulation tasks. With this knowledge, you are now better prepared to work with real-world datasets and continue your journey in data analysis and data science using Pandas.